So I'll collect that assignment here in a bit. Chapter 11, Day 5. I don't think I've ever taken 5 days on this. Expect a test in this class for Friday. It'll be short. You can bring a page of notes. It's only one chapter. Yes?
Do we have school Friday, or is it next Friday that we have off?
Mock trial? What? Wait, what?
No, like the modified calendar.
Oh, yeah. I was gonna say I didn't know of anything for this Friday. Yes, plan on a test on Friday. If for some reason we get snowed out, we'll make it for the next class. Okay? But probably at this late in the game, you're not going to get snowed out. Okay. I don't know of a holiday holding this up. So we're going to be looking at errors today. What if an error is made? What are they? The first one is a type 1 error. Type 1 errors occur when we reject the null, when in fact the null is true. We reject the null when in fact the null is true. Well, why would we do that? Well, here's an example of the situation you might have. Let's say alpha's 5%. And we make some calculations and we find that our p-value is very close to alpha. Or it could be even equal to alpha. Let's say it's very close, 0.049, so 4.9%. With the instructions that we have, and we're not changing those instructions by the way, if our p-value is less than or equal to alpha, we reject the null and accept the alternative, right? But what if there's something weird in our sample that causes our p-value to be a little lower than maybe it should be? And in fact, this is kind of a borderline. We're very close. Maybe, in reality, we should fail to reject. But our numbers told us to reject. This is called a type 1 error. So we reject the null, but a type 1 error is reasonably likely. This is what we do. We still reject the null. We might just add, though, but a type 1 error where there's a reasonable probability of a type 1 error occurring. Bless you. So how close is close? There's a calculation for that. We'll talk about that here in a little bit, but we actually don't have to worry about the calculation. We just need to worry that we know that it's out there. The reason for that is our calculators won't do it without a special program. It's called Power. But I would say that if you are not within at least a 0.5%, half a point, if you're not somewhere within a 0.5 point of your alpha, then there's really no risk of a type 1 error or the next one a type 2 error. So I'm even going to say probably if you're within a 1/4 point. So for example, if my p-value was 3%, there's no concern at all of this. They're too far apart. So a type 2 error. These occur when we fail to reject the null, when in fact the null is false. So it's the exact opposite situation. Let's say alpha is 5% again. It's probably our most common one used ever. And our p-value is just slightly more than that. And we fail to reject the null because that's what we're supposed to do. But something's going on with our sample, not by any mistake that we've made, but just some fluke, where we should have, in fact, rejected the null. So we do not reject. Yet we risk making a type 2 error. Which one is worse depends on the situation that you're looking at. Sometimes a type 1 error is worse than a type 2 error, and vice versa. You don't need to calculate a type 1 or type 2 error. You just need to know that it's out there, and it's highly likely that a AP like this question would give you something, thank you, would give you a question where they would want you to make note of that. Hey, my p-value is pretty close to alpha. Is it a type 1 or a type 2 situation? They'd be looking for you to probably mention that. At power, we just need to know about. Power is a calculation of the probability that an error is made. The probability or likeliness that an error is made. That's really what you need to know about power, but you need to know it because you're probably, if you're going to take the AP test, you're probably going to get a power question. You won't need to solve it. You'll just need to say, hey, this is what that is. It'd probably be a multiple choice type of question. So if our alpha is 0.05, this is sort of my general rule. I would definitely mention a type 2 error if the p-value is 0.0525, maybe as much as 0.055. Somewhere between those two, I'm going to say, hey, we've got a potential type 2 error. Oops, I can't spell. And if our p-value was something like 0.0475, I would definitely mention a type 1 error. And you could maybe push these out as large as 4.5% or 5.5%. But I think certainly within the quarters, you definitely need to be aware and make a statement about that. Grayson, I'll get you this in just a second. Okay. All right, let's look at a problem. Everybody got it? We good? All right, on page 731, looking at 11.53, opening a restaurant. Opening a restaurant is a questionable, scary business. They can either be really profitable or not so. So in this problem it says, you are thinking about opening a restaurant and are searching for a good location. From research you've done, you know that the mean income of those living near the restaurant must be over $85,000 to support the type of upscale restaurant you wish to open. You decide to take a simple random sample of 50 people living near the one potential location. So I'm going to make a couple notes here. The null hypothesis is that mu is 85,000. I think the alternative needs to be that it's greater than that. N equals 50. Based on the mean income for this sample, you will decide whether to open a restaurant there. A number of similar studies have shown that sigma is $5,000. Okay. So the first question is state the appropriate null and alternative hypothesis. I think I got that right here. Got the null and alternative there. What is the parameter? What is mu? Yes?
Wouldn't the alternative one be that it's less than 85,000 because then you wouldn't open a restaurant? Or it's less than 85?
The less than 85 is going to show up here. You want to see if the income is greater than 85 so that you can open the restaurant. How does that sound? You got the right idea. You're looking at it from a slightly different angle than I am. Does that make sense? Okay. The 85,000 is the income, the household income, right? So this parameter, mu, is household income. Average household income. All right, so B says, state the wait a minute, got that. Describe the two types of errors that you might make. Identify which is type 1 and which is type 2. Type 1, you do your calculations, you find the p-value. The p-value is very close to alpha. What would be a good alpha here? Let's talk about that later. Where we reject the null, when in fact the average income is 85,000. Or less. Because in this situation, this person needs more than 85,000 to open the restaurant. Type 2, we fail to reject when the income is in fact greater than 85,000. Which one's worse in this scenario? What's worse? You take the survey tells you to build the restaurant, you build the restaurant, and you go broke because the data wasn't correct. Was that worse than you get the data, you believe that there's not enough income to support your restaurant, you don't build the restaurant, but in fact there was enough income to support the restaurant? What's worse? Yeah, right. The type 1 is way worse in this case. The type 1 will bankrupt the person. Type 2, you just move on to another area and you go, okay, well, let's have a look at this spot, right? Type 1 is bankruptcy. Which is, a reality of many businesses. All right, we're going to skip E, but D. What do you think alpha should be? I don't know that I can answer that for you. I think it depends on where you stand. If you're like me, and you're a lowly teacher and you want to open a restaurant, and so where would I get the money for that? I'd have to borrow it. And I'd have to borrow it probably from somebody who has an employee named Vinny that walks around with a baseball bat stuck in his back pocket, right? We know about Vinny? It's called hard money, okay? You borrow it from the wrong people because you can't get it from the right people. And if you fail, Vinny comes along and breaks your kneecaps, right? Okay? So if it were me, I would be making my alpha very small. I'd want to be absolutely positively sure that the location I've chosen is going to work for my business. So for the conservative fellow like myself, I would want to keep my kneecaps. I don't want to meet Vinny. I would make it 1%. Now, if I was a multimillionaire and I had all these other businesses going and I just wanted to try this place out, I'd still do my homework. But I might in that case, I might go with a 10% alpha. I might be willing to risk $500,000 or whatever it costs to open a restaurant because I got all these other businesses going well anyway. So it's not the end of the world if it fails. Does that make sense? So it depends on where you stand in this case. I'm going to say, whatever it is, however you look at it, you don't want to meet Vinny. No, Vinny has a bad rep.